All right, everybody, welcome to the fifth week of school now. This is Monday, October 5th. We're starting our first actual physicsy unit. We went through a couple weeks of measurement and metric system and unit conversion and setting up those Fermi problems, but today is going to be the first day that we actually look at a real physics topic, and it's this idea of energy. And usually on a typical physics class, energy is going to show up around December or January. We're going to move it to first in this class because energy is actually the foundation of all of the sciences. And so everything else that we're going to do this year, light and sound waves and motion and electricity, it's all going to be looked at through the lens of energy. And so that's why I want to teach you this one first. I wanted to define this a very different way than you might see in a textbook. You might see in a textbook the energy is the capacity to perform mechanical work or something. I don't like that. I want to use like some plain old English, and we say something has a lot of energy if it has the ability to do stuff. And think about you. If you have a lot of energy, you can go out and do things. You could lift a mass up, you could turn a pulley, you could pull a rope, you could push a car, you could do stuff. If you have no energy, all right, if you have absolutely no energy at all, you can't do anything. You can't do stuff at all. That's a gross simplification, but it's good enough for us. Now, the idea here is that everything in the universe is going to have different forms of energy. It's everywhere. Einstein wrote this really famous formula about energy. It's called E equals mc squared. You all have seen that before. But it exists everywhere, from the tiniest little atoms all the way up to your muscles, to storm clouds, to trees. Everything in the universe has energy in it, and it's going to be in one of 9 different types of forms. So you've probably seen this in junior high. I'm imagining some of you could have listed off like potential or kinetic, and maybe you've heard this word mechanical energy before. But really, all the different types of energy that we're going to look at are going to fall into one of 2 groups. The big 3 over here, known as the mechanical family of energies. These 3 right here, potential, which should be called gravitational potential, kinetic, and elastic energy, sometimes called stretch energy or spring energy. Technically, this is also known as elastic potential energy. These 3 fall into this family of mechanical energies. And what that means is that you can physically give an object this type with your hands. All right, these other 6 down here are different types of energies, but we're going to say they fall into the other category because you can't do this with your hands. And here's what I mean. The 3 basic types of mechanical energy are going to be gravitational potential, which means that the object has the ability to do stuff because it's high off of the ground. So anything that's up on a shelf, anything that's on a table, anything that could fall down, anything that's up a ramp or up on top of a hill, because it's up high, it could, that's potential, could fall down and spin a turbine. You could tie a rope to it and have it lift a mass like a counterweight. You could have it hit somebody on the head and cause great pain. It has the ability to do stuff because it's off the ground in Earth's gravity system. You can do this. You can take an object and lift it up. I'll prove it right now. Take your stylus or a pencil in your hand and lift it up. Looky there. You just added some potential energy to that object right there. The second of the 3 types of mechanical energies is known as kinetic, and this is energy stored in the form of movement. All right, so this is any object that's moving, whether it's a bullet or a cannonball, a golf ball, a car, a sled. If an object is moving, it has the ability to do stuff. If you think about this, if it's moving, you could tie a rope to it, make it turn a pulley, spin a turbine. You could have it lift something up a hill. Because the object is moving, we say it's got a certain amount of kinetic energy. And the last one, you can do this. You can throw an object. Therefore, you can give it movement. Therefore, you can give it kinetic energy. The last of the 3, I don't know what just happened right there. What is going on? Is elastic. Now, this is any sort of energy that's stored by stretching something, whether it's a rubber band, whether it's a spring, whether it's a bungee cord, whether it's like a hair tie. If you've taken something and stretched it or compressed it, and you've pushed on this thing to, like, let's just use stretching a rubber band, for example. Now that it's stretched, there's some energy stored inside of that, and we call that elastic potential energy or stretch energy, spring energy, whatever you want to call it. But because this thing has now been elongated or compressed, it has the ability to, you guessed it, lift a mass or turn a pulley or pull on a rope or spin a turbine or something like that. You can do all of these with your hands. You can add mechanical energy. You can lift something off the ground, you can get it moving, and you can stretch it. The other six types of energy are going to be more at like the atomic level. So we talk about chemical energy. Oftentimes we'll measure this in calories. These are going to be energies that are stored inside the chemistry of the atom itself. So sugar has a lot of chemical energy because you can burn it or you can digest it. You can get the calories out of food, but you can't do this with your hands, right? Like if I said, hey, I want you to take that piece of paper right there and make it more like calorically dense, give it more chemical energy. You can't do that. There are ways to do this, but you can't. So anything that has the ability to be burned or digested or exploded, things like food or gasoline or dynamite, TNT, whatever, we're going to say has chemical energy. And that's going to be the energy stored in the chemicals or in between the atoms or molecules of a substance. The next type is, of course, nuclear energy, which is, that's not stored between the atoms, that's stored inside the nucleus of an atom. And you don't really see this a whole heck of a lot on a daily basis, but atomic weapons or nuclear power plants are involved in getting the energy out of atom's nucleus. This is also known as super, super dangerous because of how much energy is stored right there. Hopefully you don't ever see the inner workings of either of these two things happening up close. The third one we're going to talk about in this family, thermal energy, also known as heat. That's just on the atomic level a wiggling of all the atoms. And we say that something's got a lot of thermal energy or a lot of heat if it's, you guessed it, warm, right? The hotter something is, we say the more thermal energy it's got to it. You can add mechanical energies to things with your hands. You can lift things, you can move things, you can stretch things. And some of you are going to say, well, wait a minute, I can add thermal energy with my hands, and that's true. If you rub your hands together right now, they're going to get warm. But you're not directly adding the thermal energy, you're adding in the kinetic energy of moving your hands, which then the physics of your skin turns into thermal energy by getting those atoms wiggling and stuff. Next up, electric energy. This is going to be energy stored by moving the electrons either in like a static electricity situation or through a circuit. Applications of this are, of course, electricity. I mean, that one's pretty obvious. You can do stuff to generate electricity. You can spin a turbine, you can connect a battery, but you're not actually physically adding this into the system. You would be doing that by, you guessed it, spinning a generator or, lifting a counterweight up that's going to pull a turbine or something. Number 8, light energy, sometimes known as solar power or solar energy. This is some craziness. Electromagnetic radiation. We'll get back to this in February. The last one on here is, of course, going to be sound energy. These are just going to be at the molecular level, air molecules wiggling in a specific way called a wave. Examples of this would be noise. So the big idea behind physics is that a system of objects or a single object can have any number of these types of energies present. So if I had a rubber band that was stretched and held high off the ground, because it's stretched, it has this. Because it's high off the ground, it's got potential. And because it's rubber and I could burn it, I would say, well, there's probably some chemical energy in there. And if I stretched it, it probably warmed up, so there's some thermal energy in there. So an object can have multiple types of energy, and that's fine. But what we're going to see is that almost every machine or process in the universe that we use as a tool is going to be changing energy from one type to the other. So you will have a machine that has objects with one of these types of energy, and its job is to turn it into another one. A dam, for example, like the Bonneville Dam, where a lot of Portland gets its power from, there is water held up high in this dam. So here's the water level, here's the dam, right? The water level is high off the ground, and so it's got a lot of potential energy. It comes down and it falls through these turbines down here. Well, if it's losing its potential energy, that means it's turning into something else. It turns into kinetic because it starts spinning these turbines really fast. And then that kinetic energy of a spinning turbine is used to generate electric energy. So when the water comes out down below the spillway of the dam right there, now it's low, it's not high. So it lost a bunch of potential and it gained electrical energy. Now, huge idea in physics, energy cannot be created or destroyed. It can't. You can't do this. You will win a Nobel Prize. You'll be as famous as Einstein or Isaac Newton or something if you can do this. All that's going to happen is that it's going to turn into a different type of energy. And some of that is always, he says, going to be wasted as other forms. But the rest of this is going to come next time. What I want to show you guys today was these are the 9 types. These are what's known as the mechanical energy family. These are the ones that you can directly add with your hands and show you a couple of examples of what the other types of energies would look like. All right, that should be it.